everyone. My name is Brooke Young, and I'm a science and social studies teacher at Cedar Bluff Elementary School. Today we're going to talk about 4th grade science from the Week 6 packet. You can find all activities on the KCS website under the Student Resources tab inside of the Week 6 packet. A printed copy is given out at the meal distribution sites on Wednesday from 10 a.m. to 12 p.m. If this video is hard for you to understand, there are a couple of things that you can do to make it easier. First, turn on the closed captioning if it's available. You can adjust the playback speed to slow down the video. Consider watching short clips, then pause, listen, and watch again. Finally, you can ask someone in your home to watch the video with you. Stop frequently and talk to your partner about what you've heard and understood. Today's lesson is going to cover the standard of using a model to explain how the orbit of the Earth and the Sun cause observable patterns. Our learning target today is to observe and to record how the rotation of the Earth creates patterns that we can see. Are you ready to begin? Let's go. The first thing we usually do during a science lesson is come up with an essential question. This is a question that we're going to answer sometime throughout the entire lesson. Our today's essential question is, what predictable events happen because the Earth rotates? Now, in order to answer this question, we have to be clear on what the question is actually asking us for. Let's go ahead and break it down. The first word I see is the word predictable. What does the word predictable mean to you? Did you think of the word predict? Yeah. And what does it mean to predict something? It's to guess, but not just any guess, to make an educated guess, or a guess based on knowledge that you already have about a particular subject. A scientific predictable event might be an event that we already have the knowledge of to figure out maybe when or where this event would take place. So now that we understand what a predictable event is, we have to figure out what the rest of the question is asking. A predictable event is going to happen because the Earth rotates. So what does it mean for the Earth to rotate? Well, we talked about how rotate means to spin around its axis, that imaginary line that runs through the center of the Earth. So when we talk about the Earth's rotation, what we're talking about is the Earth spinning around its axis. Now that we've covered that, let's take a look at the essential question again. What predictable events happen because the Earth rotates? Why don't you take a minute and pause the video, see if you can come up with any ideas that would match our question. All right, what did you come up with? Did you think about day or night? If you did, you're on the right track. Day and night are predictable events that happen because the Earth rotates. But let's dig a little bit deeper. What does day and night really mean? How is that occurring? I don't know about you, but when I think of day and night, I end up thinking of a few more questions. Let's go over some of these questions and see if they can help us narrow down an explanation for day and night. The first question I came up with is, have you ever wondered why they call it a sunrise or a sunset? These are very strange words to describe day and night. Is the sun rising and setting? Is it moving around and going somewhere? Does it disappear at night? Well, we already know the answer to that part of the question. We've learned in other grades and through our other experience that no, the sun is not moving at all. It's really the Earth that is moving. And if that's the case, if the sun is not moving, then why can't I see it at night? That's a question that we can use to dig a little bit deeper into these predictable events that occur from the Earth's rotation. Let's go ahead and take a look at that first page in your packet and see if we can use that to help us dig a little bit deeper. On page 1 of your packet, you have a diagram. And that diagram is asking you to color this diagram to show where the sun's light will shine on Earth. Now you can use any materials you have available to color this, crayons, colored pencils if you have them at home. If you don't, if you only have a pencil, you can use the pencil to shade in the part of the Earth that will not have light, you can use the white part of the paper to represent the light itself. Let's pause the video, see if you can fill in the diagram to show where the sun's light will shine on Earth. All right, let's see what you came up with. This is the diagram colored in. Now you can see the part that is blue and green is indeed where the light shines on the Earth. When the sun's light is shining on the Earth, what event is happening on the Earth? Yeah, it's daytime. Now the gray part on the back side of the Earth represents where the Earth is not receiving the sunlight. This is the absence of light. And what event do we call the absence of light on Earth? Yeah, exactly, it's nighttime. So when we talk about daytime and nighttime, and we're referring to the Earth's rotation, what are we talking about? Yeah, we're talking about the spin that the Earth is doing on its axis in time to show light and darkness. Exactly. Now, I don't know about you, but a white flat piece of paper does not really help show the rotation or the spin of the Earth. It's nice to show the light and the dark, but it doesn't really explain the spin. It would be great if we could go on a field trip up to space, see and observe the Earth actually rotate on its axis. But until that's a possibility, there are other ways that we can communicate how the Earth rotates around itself to show day and night. And you can actually complete this in an activity with a few simple objects from your house. Let's take a look. You can make a three-dimensional model of the Earth's rotation. All you need to complete this is a ball, tennis balls will work, a ping pong ball, even a piece of Play-Doh that you roll into a ball can count as the Earth. You need a flashlight, a light source of some sort. A lamp without a lampshade would work great to represent the sun. And then finally, you need something like a sticker that you can stick on the ball to represent your position on the Earth itself. Once you have these together, you're ready to make a 3D model. Now you're welcome to pause the video, collect these supplies, and make your model along with me, or you can continue watching the video and my examples, and then you can make your own 3D model at home afterwards. All right, let's take a look at what we see. You can see here from these two different 3D models what we mean by the Earth's rotation. When you hold the ball near the light, you're representing the Earth and the sun. If you turn the ball one time around, you are completing a rotation of the Earth. You can see in the first picture that the sticker is facing away from the sun. So that means that your position on Earth would be experiencing what event? Yeah, it's experiencing nighttime. As the ball continues to turn, however, your sticker is now facing the sun. What event is now occurring on your position on the Earth? Exactly, daytime. And one rotation of that ball, or of the Earth, is representing what event? Yeah, it's a day, or 24 hours. It takes us 24 hours to make one complete rotation of the Earth. And you just demonstrated that in your own home. So, this is great. We enjoy making models, but let's get real. Science isn't fun until you've done some kind of investigation, right? Well, we've got an investigation for you. Let's take a look at another observable, predictable event that is occurring, and you can actually see parts of it in the picture. I was having trouble making sure that I could get this picture without showing a shadow. Shadows are another event that we need to discuss. What are shadows? That's something we need to figure out. Did you ever notice that they change throughout the day? When you move and change your position throughout the day, your shadow changes. How does that occur? And finally, do you think shadows might have something to add to this essential question? Well, there's only one way to solve this problem. We've got to investigate. In order to investigate, we usually start with some background knowledge. So let's take a look at this image right here. This is the picture of a shadow of a tree. And a shadow is simply the absence of light. Like when we were looking at our diagram and you saw part of the earth shaded or part of the earth in a shadow, that was due to the other half of the earth blocking the sun's light. When a tree stands in the path of the light source, the sun's light, it blocks the light from going through the tree. And what you get on the opposite side of that sunlight is a shadow, the absence of the light that the tree blocked. So now that we understand what a shadow is, let's make a prediction and see if we can answer this question. On page 3 of your packet, you have a space to write down your prediction. Let's see if you can answer this question. How do you think that the time of day will affect your shadow? Will it change? Will it move depending on time of day? Take a minute, pause the video, and see if you can write down your prediction to this question. All right, if your predictions are written down, let's go over the instructions for this investigation. Now, if we're going to talk about the sun, and we're at home, what better place to do this investigation than out in the sunshine? All you need is a few simple tools and a day to complete this activity. You are welcome to pause this video and come back. You are welcome to go over the instructions and then complete it at a later date, and then we can go over the questions at the end. Your investigation: how does time of day affect your shadow? Here are the materials that you're going to need to complete the activity. The first thing you need is a toy that will cast a shadow. You can see in my picture here that I chose a T-Rex, mainly because he stands up on his own and of course he casts a shadow. You also need a piece of sidewalk chalk. Doesn't matter the color or the size, just something that you can use to trace your shadow. You also need a ruler or a tape measure, something that you can use to measure the shadow. And then finally, you're going to need page 3 from your packet. All right, let's go over the directions. All you're going to do is you're going to choose a time of day in the morning, before the middle of the day, before 11 a.m., and you're going to put down your toy in the sunlight, on the sidewalk, somewhere where you would be able to trace using your chalk. Place the toy down, trace your shadow, and then fill out the chart on page 3. You see it's got a spot for your time of day, what time of the morning, so jot down your time when you put it out there. Then you're going to measure that shadow that you traced, see how long it is. You can measure it in inches or centimeters, whatever your measuring item has available on it. And then the last category asks for the direction of your shadow. Is your shadow facing to the right or to the left of your toy? Maybe it's in front or behind it. Go ahead and write down the direction that this shadow is from your toy. You're going to complete the exact same steps again in the middle of the day. Write down the time, the length of that shadow, and its direction. And then you're going to do it one more time in the evening before the sun sets. Write down that time, the length of the shadow at that time, and its direction. Once you complete this activity, you'll be able to answer the questions at the end. If you want to pause the video now, complete your activity and come back, you are more than welcome, or we can continue before. All right, we're at the last step. Once you've completed an investigation and you've taken down your data and you've compiled your information, the last thing you need to do is be able to communicate it. What does it mean to you? And that's what we're going to go over together. So the first question we have is, at what time of day was your shadow the longest? Now everybody might have a slightly different measurement depending on the time of day that you actually put your shadows and trace them out there. But hopefully your longest shadows occurred either in the morning or in the evening? And we'll talk about why that's the case in a minute. So the morning or the evening will probably be your best answer. The second question, at what time was your shadow the shortest? Hopefully, you've noticed a pattern here. If the longest shadow is in the morning or the evening, when was your shortest shadow? Hopefully it was midday. That's when the shortest shadow is occurring. We'll talk about why in just a second. The third question, what causes the shadow to move and change lengths throughout the day? If you watched your shadows throughout the day, you noticed that they changed position. Not just how long or how short they were, but you noticed that they changed position from one side of your toy to the other throughout the day. How does that happen? What's causing the change in your shadow? If you watched the sun and tracked it, you might have figured out that the sun's position in the sky is moving. Is the sun moving? No. The earth is moving. What is changing the length of your shadow is the angle of the light that is hitting your sidewalk and your toy. Throughout the day, as the earth is rotating, the angle of the light is changing, and that is causing your shadow to lengthen, shorten, and change position. The last question. Based on your observations, was your prediction correct? Why or why not? Now, if your prediction is wrong, does that mean you've done something wrong? Absolutely not. A prediction is basically knowledge that we already had to make a guess. Your guess doesn't have to be right. Hopefully you've learned why your prediction was wrong and what steps you need to take to make sure that you know that information in the future. If your prediction was right, congratulations! You completely understand how shadows are affecting day and night. You understand the angle of the sun's light. So let's go back to that essential question one more time. What predictable events happen because the earth rotates? We said at the very beginning, day and night would be events that are predictable that occur because of that earth rotating or spinning around its axis. We dug a little deeper and we discovered that not only is day and night a predictable event, but shadows moving and changing due to the position and angle of the sun's light throughout the day as the earth is rotating is also a predictable event. Can you think of an invention that was made because people have figured out the predictable pattern of light shifting throughout the day and shadows occurring? If you said the sundial, then you would be correct. Early human beings figured out that a great way to tell time throughout the day is to track the position of shadows using objects like you did out on your sidewalk. Thank you so much for joining me today. I enjoyed having this lesson with you and talking more about the earth and its rotation. Don't forget when you're done to clean up your activity and to wash your hands. If you enjoyed this science lesson and you have the ability to take pictures, we would love to see some of your investigation images, your diagrams, or your models. If you want to tweet us at @KCS Science, we would love to take a look at those pictures. Thank you so much for joining us. Have a great day.